Hello class. For our video lecture this week, I'm going to take one of the problems that you're asked to complete in the homework, and I'm just going to work through it to show you my process, and hopefully that will help you to solve the problem. So the problem that I've chosen is the parallel processing problem off of your homework. So I'm going to just read it through to you real quick, and then I'm going to work it out on a whiteboard that I have sitting over here. So the question says, parallel processing uses two or more computers working together to solve a single problem. Using parallel processing, two computers can solve a problem in 15 minutes. If working alone, one computer can solve a problem in 16 minutes less than the time needed by the second computer. How long would it take the faster computer working alone to solve the problem? Okay, so to solve this problem, there's three pieces of information that we have here. First of all, the time for the two computers together to solve the problem is 15 minutes. So I wrote that on the whiteboard here as t equals 15. And then we have two other pieces of information, which is the rates of the two computers. The first computer, which is the slower computer, I've let the rate be r. And the second computer, which is the faster computer, takes 16 minutes less than the time needed by the slower computer. So we're going to take r, the time needed by the slower computer, and subtract 16 from that to get the rate of the second one. And then to set up this problem, this is a work problem, so the way we're going to set this up is we're going to take 1 over the rate of the first computer times the time it takes them to do the job combined, plus 1 over the rate of the second computer times the time it takes them to do the job combined is equal to 1, because they're just doing one job total here. So let me write that down for you. Okay, so over here on this side now we have our problem written out. 1 over r times 15 plus 1 over r minus 16 times 15 equals 1. Now to solve this problem, we have fractions to deal with. So we have to get rid of those fractions. The way we're going to do that is the way we would if they were numbers. We're going to multiply each one of these terms in this equation by the common denominator. And the common denominator for this is r, which is the denominator of the first one, times r minus 16, which is the denominator of the second one. So I'm going to go ahead and write that down so you can see what that looks like. Okay, so that's this line here. I've got r times r minus 16 times 15 over r, so that was taking the common denominator times that first term, plus r times r minus 16 times 15 over r minus 16, which was taking the common denominator times that second term, is equal to 1 times r minus 16. So the third term on this side of the equal sign times the common denominator. Now you'll notice that this term doesn't have a denominator, but we're still multiplying it by the least common denominator. In order to not change the equation, if I multiply even one of these terms by something, I have to multiply all of the terms by that. All right, so now we're going to simplify, and I'm going to try and do this so that you can see what I'm crossing out as I go here, because I think it'll make a lot more sense. We're going to just cancel if we see the same term in the numerator, and in the denominator we cross it out. So I have an r in the numerator, and I have an r in the denominator, so that gets canceled. Over here, I have r minus 16, the entire term, in the numerator, and I have r minus 16, the matching term, in the denominator. And then over here, of course, I can't cancel anything because I have no denominator. So now I'm going to rewrite this line without the denominator. So it's going to be r minus 16 times 15 plus r times 15 is equal to r times r minus 16. So I'm going to write that down real quick. Okay, once I get that written down, now I no longer have fractions, so I'm going to solve this just like I would solve any algebraic expression or equation. So at this point, I'm going to get rid of my parentheses by distributing 15 through these parentheses and r through this parentheses. So that's going to give me 15r minus 240 plus 15r is equal to r squared minus 16r. So now we have that. At this point, I have an r squared, which tells me that this is a quadratic equation. And with the quadratic, the way to solve that is to put everything on one side of the equal sign and get the whole thing equal to 0 so we can factor it and apply that zero product principle. So let's move all of our terms on this side of the equation onto that side of the equation just using our algebraic principles of addition. All right. Okay, so what we're left with is 0 is equal to r squared minus 46r plus 240. Now at this point I need to factor, and that might be a little bit of a difficult step. We have to find two numbers that we can multiply together to equal 240 and add together to equal negative 46. And you may have to just play around with some different factors of 240 here to find it. There's no quick and easy way to figure it out. What I will tell you though is because this is positive and this is negative, the only way that we can get a product that's positive with a sum that's negative is that both numbers are going to be negative numbers. And what I find out is that if I multiply negative 6 and negative 40 together, I get 240. And if I add negative 6 and negative 40 together, I get negative 46. So those are my terms, or those are my numbers that I'm looking for. And since I have a coefficient of 1 here, this can factor directly into 0 equals r minus 6 and r, sorry, trying to write and video at the same time here, and r minus 40. So that's what we end up factoring that into. And now we apply the zero product principle, set each one of those equal to 0, and solve. So let's do that real quick. Okay, so when I solve that, which I did right over here, I get r minus 6 equals 0, so r equals 6, and r minus 40 equals 0, so r equals 40. Now we have two positive answers here, so we have to figure out which one is the correct one. And to do that, we're going to look back up at the top up here. The faster computer was r, and the slower computer, sorry, reverse that, the slower computer was r. The faster computer was whatever the first computer's time was, minus 16. So if I take the slower computer's time to be 6, and I put that in up here, I get 6 minus 16, which gives me a negative rate, which isn't possible. So r equals 6 is not a solution. But if I take 40 and I put it up here, I get 40 minus 16, which is 24, and that is the rate we're looking for, the rate of the faster computer. So that's our answer. R is equal to 40 minus 16, which is equal to 24, which I wrote down way down here in the bottom, 40 minus 16, which gives us 24. So that's our solution to this problem, and hope you find that explanation helpful as you're working on these problems.